mean, I don't want to over-explain things, so let me just say this. If you have an equation in two variables, you can sketch its graph, which is the graph of all its solutions, right? If the graph of the equation passes the vertical line test, then we have y as a function of x from an equation. So then we have y as a function of x from an equation. Again, the book I don't think says this. The book gets a little more specific. You need y to be a unique expression of x. But for now, this is good enough. Just sketch the graph of the equation. And what's nice is when you have this, you can generally get y in terms of x. And thus, you can get an algebraic expression or formula, so to say, for f of x from x. That's what the equation would tell you. Although you may not be always able to do that, but you are able to get function values from the equation. In fact, you can replace y in the equation with f of x, where f is the function. F is what you're calling the function. I mean, this is what I was trying to say before. We'll do some examples. I know it might be a little confusing. I understand. This is what I was trying to say before. Namely, from any equation in two variables, you get the graph. Okay? And from any graph, you get the relation, right? We know when a relation is a function. So there is a connection here. In other words, what we're saying here is related to relations and graphs and stuff as before. But again, graphs of equations are generally going to have infinitely many points. So theoretically, you could write the relation, but I wouldn't. That would take forever. So, okay, at least, based on what we know. So, but this is just what I'm trying to say. So it might be over-explaining it. So basically, for an equation, you just sketch the graph and you see, does the graph pass the vertical line test? That's all you have to do. Let's do some examples. If you remember this here, we'll see the graph shortly. The graph of this is a non-vertical line, right? If you have ax plus by, or in this case minus, equals another number, you have a line that's not vertical. We also know it's a line because, as I did here, you can solve for y in terms of x. So we get y. So solving for y in terms of x, we get y equals -6 plus 2x, right? What did I do? I just divided everything by -2, the coefficient of y. And I brought the 4x to the other side. So we have y equals -6 plus 2x. That's a line, non-vertical one. So it gives us y as a function of x. In fact, replacing y with f of x, we get this. So now we can calculate function values by algebra, right? For instance, if we wanted f of 1, that's how this is read, f of 1. You just replace x by 1. We get -6 plus 2 times 1. Well, that's -4. So f of 1 is -4. Again, I'm just replacing x with the number. What's f of 2? Same idea. We get -6, right? Plus 2 times 2, right? X is 2 in this case, which is -6 plus 4, which is -2. And f of 3 is -6 plus 2 times 3, right? I'm replacing x by 3, which is 0. Yeah?
So to start out, we just got to move the y outside to the left, and then we just proceed like a normal equation for the most part.
Yeah.
Okay. And you don't have to do anything to move the y. You just move it. Like you don't have to
You can solve for y in terms of x.
No, but to get the 2y on the left side, at the beginning there, you just simply move it? You don't have to like do any like solutions to get it over there. You just move it.
Oh, no, you just do basic algebra. Like I just subtracted 4x from both sides. I mean, I know I
Okay.
didn't show it, but I'm hoping everyone can see it by now.
Okay, I was just making sure.
That's okay. Good
Yeah,
question.
thank you.
You're welcome. So this is what we have here. Okay. And again, all we're doing to get the function values is we're replacing the numbers. We're replacing x with the numbers. So for instance, f of 3, right? That's going to be, what would you do? You'd replace x by 3. You get -6 plus 2 times 3, which is 0. And if we were to graph it, we would actually get the points. Like 3, 0 is on the line, right? We got f of 3 is 0. So when x is 3, y is 0. When x is 1, you can't see it from here, but when x is 1, y is -4. F of 4 is 2. We can see that 4, 2 is on the line. I mean, I didn't calculate f of 4, but if you did, you would get f of 4 would be 2. F of 2, you can see here is -2, but that's what we get here. So again, for equations, right, you sketch the graph, and the graph passes if the graph passes the vertical line test, then you have y as a function of x. And as someone just asked, which was really good, you can solve for y in terms of x, get y equal to other stuff, and then you know how to get output from your input. The idea is that you replace y with f parentheses x, and you can do stuff like this. I mean, I hope that makes sense. I think it does. I mean, we'll definitely practice with it. So I can always give another worksheet, which I plan on doing anyway. Okay. So, all right. So this here, again, is our line. As we saw already, you have a non-vertical line here. Okay, that's good. I don't know if I showed you the graph of the absolute value, but this is what it turns out to be. We have y equals the absolute value of x. But this defines y as a function of x. If you look at the graph here, you can see that, oh yeah, this passes the vertical line test. In fact, let me try drawing some vertical lines. Right? You can see that, oh yeah, well, use your imagination a bit, but the vertical line cuts through the graph just once. See? So because of that, the graph does give us y as a function of x. And again, you can calculate different function values. You replace y with f of x. So what do we get here? Well, f of 0, for instance, would be the absolute value of 0, which is just 0. F of 1, that's the absolute value of 1, which is 1. F of -1 is the absolute value of -1, which is also 1. Good. Okay. Are there any questions about this? Okay. Well, again, these are just some other examples. So if you have this, well, again, you have a times x plus or minus something times y equal to a number. That's a line. So we do have a line here, a non-vertical one that is. So this does give y as a function of x. Now, what exactly is that function? You can solve for y. I mean, again, I didn't show the calculation, but you can basically just add y to both sides and then subtract 1 from both sides. And from here, you get y equals 4x minus 1. So this gives y in terms of x, and we have y as a function of x. I just basically called the function f. But as I said last time, there's other letters you can use. People use letters G or even H. So I replace y with f parentheses x, which again is read as f of x, and we get this. I just replace y with f of x. So here, if you give me an x, I can easily algebraically calculate the output. Here's another one, x times y equals 1. Now, does this define y as a function of x? It turns out it does. I mean, I did show the graph of this before, which is also over here. Now, I know it's a little tricky to see as you get close to the y-axis. This does pass the vertical line test. So we have y as a function of x. In fact, again, you can solve for y, right? And we get y equals 1 over x. You basically divide both sides by x. So we have this. So again, I get y equals something in terms of x. And then I just replace y with f of x. That's all I did. So in this case, the function is taking an x and gives you back 1 over that x. And as we saw, 1 over x, you can't define that at 0. So, well, we'll get to that shortly, actually. Let me pause the recording.